Okay, this lesson we're going to work out problems involving semicircles and their perimeter. What we've been looking at most recently is the idea that for any circle, the circumference can be calculated by the diameter multiplied by this number just over 3.1415, which we give the symbol pi. C equals pi times d. That gives you the circumference of the whole circle. So of course it stands to reason that when we're dealing with fractions of a circle, we just have to amend our formula or do something to make sure that we're only working out parts of the circumference. So here's a particular example here. We're working out the perimeter of a semicircle. Now a semicircle is therefore going to have this kind of curved part is going to be half of the circumference of the circle. And the circle, if we were to continue it, hopefully it would be kind of obvious that the 14 centimeters across the way becomes the diameter of the circle. So the straight edge in a semicircle is really the diameter of the kind of virtual circle that we would complete. So there's two parts to this solution. To find the perimeter of a semicircle, we need to find the curved part, and we need to then add on the straight part. Okay, so it's easy to just put down some numbers and for it to make sense to you, but not anyone else. So it's really important that you think, how can I communicate what I'm doing here? So there's a word that we can use for the part of a the part of a perimeter or part of a circumference. It's called the arc. An arc is a fraction of the perimeter of a circle. So an arc is part of the circumference when we're not using it all. So what we could say here is that the length of the arc, and we're not talking about Noah's Ark here, it's ARC, not ARK. So we can say length of arc is equal to, well, we can come up with a calculation because we know that the full circumference would be pi times d. So we can add the fraction in front of it. So if I, for instance, were wanting a quarter of a circle, I'd put the fraction 1/4 times pi d. But here clearly we're looking for half of a circle. So I can say that the length of the arc is a half multiplied by pi times d. Okay, so that means that I've got a half. We're going to use 3.14 as our value of pi. The diameter is this full line 14 centimeters, and I can use my calculator to work out half of 14 is 7, and 7 times 3.14 is 21.98 centimeters. Okay, now the good thing about writing words down at the start is that it's very clear what that number represents. It doesn't represent the perimeter, it represents the curved part of the shape. So if I remind yourself, then we're going to take away this part just so that we can see what shape we started with. So the perimeter is going to be the length of the arc plus this another 14 centimeter line. So we're going to put the perimeter. What I don't want you to do is just to do equals 21.98 plus 14, because they don't equal each other. It's really important when you do mathematics that it makes sense, just like all the grammar that you use when you're writing out words and full stops, capital letters and spelling. So we want to work out the perimeter. So perimeter is equal to, we could do 21.98 plus 14. 21 and 14 is 35, so 35.98 centimeters. Okay, so part of it is the calculation, but part of it also is thinking what's the best way of communicating what I'm doing and not just writing down random calculations that then don't make sense when someone else reads it. Okay, so that's one example. Let's have a look at this other example here. Calculate the perimeter of this shape. We've effectively got a rectangle and a semicircle put together, and it's asked to calculate the perimeter of it. So let's count just how many numbers are in my perimeter. I've got the rectangular part means that the base is 3. We've got 4 centimeters as a straight edge, which 4 meters rather, which means that this is also 4 meters. And then it might help, and you could do this if we kind of draw So you're always going to draw the shape anyway. And then we've got a semicircle at the top. Now, again, semicircle, that line that cuts it there is also the diameter. So we can write in the fact that we've got 3 meters there. So we've got an arc at the top, and we've then got 3 straight lines. So let's concentrate on the length of the arc first. The length of the arc is equal to, well, it's a half of the full circumference. So it's a half times pi d, which is a half multiplied by 3.14 multiplied by the diameter of the circle. If it were a full circle, of course, the diameter is that length 3. Okay, so I can put 3 in here. I can use my calculator. Oops, that was a bit clumsy. A half times 3 times 3.14 gives me 4.71. 4.71 watt meters, the units of length. So I've got my arc length. So what I need to do, I need to add 4 and 3 and another 4. So my perimeter is going to be the length of the arc plus 4 plus 3 plus another 4. What does that give me? 4, 4 and 4 is 12 plus 3 is 15. 15.71 meters, and that's the perimeter. I put my words in to explain the different calculations, and I believe that my whole working can tell the story properly. Okay, so working out perimeters involving semicircles at the moment, we're always going to use the half, but we'll move on to other situations where we might have to use a quarter or a third or some other fraction. But for the moment, we're going to use a half times pi times d, but most importantly, it's how you tell the story of your problem solving. So have a go at questions like that.